the demo gods have mercy on me. I have committed to a lot of tech in this talk, but we'll see what happens. So yeah, if you haven't already, pull out a mobile phone or a laptop or a convenient device, because this is an interactive talk. So you'll want to be on this if you'd like to participate, which would be cool if you did. Okay. So, diving in, the unbearable weight of glue. My goal with this talk, I'm surprised that you're here. Glue code, isn't that amazing? My goal at the end of this talk is for you to walk away not feeling like, yeah, glue code, but more feeling like, glue code, I hate it. Okay, first a tangent though. Why are you here? Like, why are you physically in this room? Here's a picture of me and you. This is me talking at you. Sometimes, maybe one of you will get to do this and everyone else has to listen. But this picture is the same as this picture, and this picture is free. And you can't even, you can't pause me, right? And you can't fast forward. And you have no ad block. So I like to do a bit more interaction in my talks, trying to see whether there's a interaction mode that is a little bit in between, like us conversing in like a panel or me just talking at you. So I'm going to try to do something like this. So that's what the app is for. So first things first, they say know your audience. So tell me then, how are you doing? First up, let's start easy. Okay. A few people are doing not so well. Maybe partied too hard last night. My apologies. Next question is, why are you here? I mean, physically in this session, you could be watching this on YouTube. So presumably you've come to this conference for a different reason. Right, so break from work seems to be the... Don't worry, this is completely anonymous. I should have said I'm not collecting any personally identifiable data, and I'm not going to sell this to anybody. I'm just going to use it perhaps afterwards to do some analysis. But yeah, okay. Curated discovery, a lot of people are here for that. A lot of people here for the social side. And 6 people are here for love. So it's possible, guys. It's possible. Keep trying. Okay, let's do the next one. What fields are you in? These are multiple choice. You can select multiple if you feel that you span across a couple. Okay, so mostly developers. We've got some students here, academics. A bunch of people are in other fields. So throughout this, there's a comments box at the bottom. I'm not going to read everything. I see some of the comments come in, but I'm not going to focus on them. But the cool thing about this, for me at least, is that if you like something or you hate something or you're confused about something, you can tell me literally at that point, and afterwards I'll have a timeline throughout the talk, which I think is better overall in terms of feedback. Cool, let's go to the next one. Experience in your fields. Okay. We got a lot of really senior people here. I was expecting maybe more of a breadth. Okay, it's balancing. Some people are changing their mind. Maybe some people have been in tech for a few years, but it's felt like a decade, which is understandable. Okay, and the last one. What is the scale of your current project? So this is hard to compare, but I want to get a rough estimate. So think like how many users in real time would you have to handle like at the same time? Okay, amazing. So part of my punt, or I think any speaker's punt when they're presenting a talk, is that we're going to somehow guess the people in the room, what your kind of background and your interests are, and whether the things that we say resonate. So my talk is pretty heavily geared right now at that 0 to 1K, right? Like I think there's things at that scale, at least for me, 99% of my career has been things within that scale. So yeah, hopefully this will be really applicable to you. The higher up we get with this number, the more different kinds of problems we have that maybe cause conflicts with some of the things I'm talking about. I think there are solutions, but they're a bit more work in progress. Okay, I forgot, there was one more. So languages you currently work with, I'm really sorry if your language isn't on here. I just tried to figure out what would be the most likely languages that would actually appear in this room. But it'll be sorted by kind of popularity of responses. Again, you can choose multiple. I'm just curious the kind of people that I'm speaking to and what your background might be. Okay, pretty cool. We got some laggards lower down. Yeah, that's pretty interesting. Let me ask you this, if you will. Tap on all the options, like unselect all of them. Let's go back down to 0. Undo, 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 undo. Excellent. Now choose your favorite language. Even if you don't get to work with it, just like the one where you're like, this brings me joy. And if no languages bring you joy, please just don't answer. Yeah, if multiple give you joy, yes, you may. I permit it. I'm surprised because you have to use them together in context switch. Like, that sucks, but sure, yeah. Okay, great. So, quickly about me then. I know about you a little bit. This is my context and where I'm going to be speaking from. So I'm a developer. I've been at this getting close to 20 years, which is terrifying. Like I said, my scale kind of 0 to 1. There's been points in my career where I've done 10K stuff in e-commerce, but it's really low scale and really high complexity is how I would characterize it. I'd consider anything up to like 100K low scale. Elm and Haskell are the languages that I love. JavaScript, TypeScript, Ruby, I work in professionally. The other languages there, I like the history of where I came through, from C to Java to PHP to SQL. So my really early exposure, I think in Java, that was my exposure of static typing, and I hated it, and it was awful, and I never came back to it again for maybe a decade until a friend of mine said, Haskell is the only language on the planet worth learning, and it made me really angry, so I kind of like anger learned for like a year, and then it finally clicked, and I was like, oh, this is pretty good. So with that, let's actually dive into the talk. So the unbearable weight of glue. Let me try and motivate you first with the problem. Here's the problem. Maybe you've got this in side projects, maybe you've suffered this at work. We're building a web app. If you're not in the web dev world, similar front-end interface, some sort of back-end processing, and some sort of storage. And I think we talk about it. Can you see those colors? No. Is it just me, or is it it's just the contrast on the display screen. Okay, and so there's actually a fair few things that we hide here, which is when the front end is communicating with the back end, there's actually more components there. I think we don't really talk about them. There is encoding, right? You have the type or the value system in the language that you're using the front end, and you have to convert that to something, probably JSON. Even if you're not using JavaScript, you still use JavaScript object notation because that makes sense. Then there's a transport, right? There's a HTTP, or maybe you've got some sort of lower level thing, maybe using TCP. There's decoding on the back end. You're taking that JSON or whatever it is, converting it back into the types and values that you have within the language that you work with. The same thing again happens from backend to storage. I'm not going to draw out all the layers, but I'm just going to say it's querying, right? And in this case, it's like SQL would be the thing that you're transforming into it, and then there's some semantics that are happening behind that, and there's stuff's coming back. Layer underneath all of that, hosting, deployment, and migrations. Who's feeling excited about starting a side project right now? Okay, who's feeling excited about starting a side project now? Now you've got all the glue to like join all this stuff together, right? And then, you know, if you're into TDD, or if this is in a workplace environment, then things get even more exciting. Now we've got tests for all of these things. And then we've got tests for all the glue in between all of those things, right? Then maybe we have integration tests, like we're not sure if those things work together. You get the point. Acceptance tests, now we're mocking because the database is slow, we can't run that in line. That's more code. And then we get to the point where we're like, okay, well now we need continuous integration to run all this stuff. We need package updates, we need security updates. Yeah, that's a lot. I think that's a lot. So I'm going to start with some definitions. I'm not really one for trying to invent terms, but I've been looking for a long time to find a term that explain this. You can drop it in the comments if you're aware of it. I'm not aware of it yet. But I'm going to start what I've been calling a semantic boundary in lieu of a better term. So this is a transition point between two non-equivalent technical domains. So kind of everything I was showing you now. Here's an example of a subset of it. We've got our language, we've got JSON, we've got HTTP, for example. And the reason that I'm calling these boundaries specifically, some of you might be like, well, my HTTP library is like, it's integrated with JSON. Well, it's because the semantics that we can describe in this layer are different from some of the things that happen in this layer, right? Like we got the notion of headers and the body and HTTP status, and we don't necessarily model those in the middle layer in what I would call the serialization layer, right? So we could give names to these kind of concerns that we have traditionally, and I would call the bits in between those, where the semantics, one semantic ends and another semantic starts, that would be the boundary. So transition point between two non-equivalent technical domains. The reason I say technical is obviously semantic boundaries exist in business logic and lots of other areas, but here I'm focused specifically on the technical one and what that means for us. Glue code, the point of this whole talk. Glue code bridges semantic boundaries, and I would say that's exclusively its purpose, right? So much so it doesn't have any direct relation to business objectives. So I'm not talking about code where you receive something from one of your third parties and it's bad data and you kind of normalize it and massage it to get it into something nice, right? Like that's maybe mixing the two concerns, but yeah, in general, when we're looking at the concept of glue code, or at least the isolation of the idea that I'm talking about, we're talking about stuff that's bridging semantic boundaries, has no direct relation to business objectives, and kind of crucially, it has no safeguard against external changes. So usually the glue code, at least how I'm defining it here, is not in any way aware or have any mechanism to be protected against that if the semantics on either side change, that it will stay resilient. And I'm not talking about the case of like error handling, like you may have a catch-all error case and go, oh, it's handled. What I mean is that if the semantics change, that the glue code is still valid or it still makes sense. Okay. I'm going to give a couple of examples and talk about some strategies. The first, some context for where I'm coming from. And the things that I'm speaking of, the strategies I'm speaking of, are things that I've observed in the Elm community and a project that I've been working on for the last 5 years. And these things come from a particular context of being possible, right? So Elm, if you're not aware, it's a delightful language for reliable web apps. The short primer is it's a functional language. It's statically typed and inferred, so you can remove all of the type annotations and it's still completely typed. All the data is immutable. All the functions are pure. Which means that you can replace any call to a function with its result, and it has no side effects, right? So it's both pure and referentially transparent. It doesn't call out into the world, it doesn't read into the world. There is no concept of null, undefined, and exceptions. You can't throw an exception in Elm, there's no syntax for it. You can't express a null or an undefined, there's no syntax for it. No functions return these in practice. No runtime exceptions in practice is the kind of hallmark thing that the Elm community kind of waves about. And we say in practice, because yes, theoretically it's possible if you run out of memory, if you have an infinite loop. But we say in practice because we've got lots of anecdotes of really large companies using Elm in production. Their JavaScript error stack trace is like 200,000 errors over a 1-year period, and their Elm stack tracing is literally 0, or like 1, the one time they did the naughty thing that they knew they shouldn't do. So this is something that, in practice, you really feel this property. Okay, so what's the impact of glue? Why are we caring about this? And why am I talking about it? Glue erodes confidence. And let me explain a worked example of that. Think of an application you have. Let's say there's a module in there. Let's say there's the auth module. Say this started originally, you've grown it, it's now 30,000 lines long, it's got all the concerns inside it. So your team goes, this is really hard to work with. We're going to split it out, right? We want to split out sessions and users as concerns, and then we want to have the auth as something that works with those. And so if you want to grab your phones or unlock, go back to the app, I'm going to ask you a question in a second. But the question here is, in your view, is this a boundary? Have we introduced boundaries here into our code? Okay. Lots of people unsure. A bunch of people are like, no, this definitely isn't. I love this. We are so torn. This is why we argue on the internet. So let me now ask this question. If all of this is typed, so you're in your language where it's completely typed and it's exhaustive. I'm not saying it's like TypeScript typed. I'm talking like real typed, right? What do we think now? Let's redo your thing. Do you think that there's a boundary here? Okay, we've shifted some opinions to no, but there's still quite a lot of people that think yes. So in Elm, this wouldn't be a boundary. And the reason for that is, remember our three things that we said. It bridges two semantic boundaries. It has no relation to business logic, so that's fine. These things hold, right? So we're on the road towards glue code. But then the last one was that it has no safeguards against the semantics changing, and that's not true here. So in Elm, if you changed anything about the interface within session, that would catch it in the auth side, right? Now, I know that some of you may be thinking, oh, but what if the implementation changed? In this case, I'm purely talking about this from like an interface point of view. I'm talking about, we're talking about the glue code joining these interfaces too, not the glue code being responsible for holding the invariance of the functionality within it. Hopefully that's making sense. Let's take another example now. So here is another approach, right? This is me 10 years ago in all my wisdom. Microservices, right? That's the way. So what we're going to do is we're going to split this into two separate services, right? I'm going to put these to two sides. Do you think that there's a boundary here? Okay, for the 7 people that are not convinced, there's up to 16 boundaries that we've introduced, right? This is just for splitting for 2 microservices. And you may think, okay, this is just how it is, right? This is our industry, this is what we do day in, day out. I haven't even yet like slapped on race conditions, like concurrency bugs, like to me this is a disaster. So the question, and I think we was asking this question before, but in the wrong order, this is what I wonder, is the added complexity worth it? Do we think that added complexity is worth it of introducing those additional boundaries? Yeah, so lots of people sitting in the unsure, and I'm really curious afterwards. I'd like to do some analysis to augment these stats with what you said in the beginning, what your language context is, what kind of scale you work with. I wonder if we'll see some patterns about where this dissenting opinion comes from and why we can't agree on whether or not microservices are a good way to tackle glue or not. I'm not going to go that track, but I am going to bang on about it a little bit more. In terms of, okay, semantic boundaries, maybe like you have this terminology for it. It's kind of obvious, right? Like I'm pointing it out. It's nothing new. I've just given it a moniker. But why should we care? So I think this is something that I've seen picking on Jamstack. I have no shade against Jamstack, but this is just something I've seen in the wild, and I've seen this increasingly in the wild, and I think it's just symptomatic of us grappling as an industry, trying to deal with all this complexity, trying to find nice ways to do it. But I think this is kind of sneaky, and I know in my career, I've definitely dragged in a lot of boundaries, not realizing what I was buying myself into. So Jamstack, on their website, says they are the new standard architecture for the web. So I was like, oh, standard. I'm like, I guess I should know this, right? I'm a web developer. So here it is, what they pitch on the website. So you've got client, web server, app server, database, CMS. I don't know why the CMS isn't talking to the database. But it's kind of, it's gray, it's in a stack, looks kind of boring. I'm like, yeah, I guess that is old, right? Like that kind of sucks. And so the solution is this, right? It's got colors. And like, there's these little things and they're kind of, I don't know if you can even see them. Is the contrast good enough? Yeah, they're like kind of obscure. There's this microservice on the side. And I'm like, this is better, right? Like there's 3 things. I'm like, okay, I should learn. And CDN, I don't know what, cool, I have to learn content delivery networks. But like it's like the age of AI. I was really a fan of like NCIS when I was a kid. When they're like, zoom, enhance. Oh no, let's lift that up. It's just the same thing. We just got more of them now. It's not actually any better. again, no shade against the Jamstack guys, but you may have heard the adage, like everything old is new again. I would claim everything old is now buried under reams of abstraction, and it's really tiring. So this is why I think semantic boundaries matter. And I think, at least for me, when I started seeing these, I kind of just saw them everywhere. And half my job was like, I'm just dealing with glue code all the time. Yeah, why does this matter? I think it's because semantic boundaries increase uncertainty, right? Have I handled all the cases? I don't know. Like, I don't even know half of what's in these protocols. They increase the code surface area, right? We write the glue code, we write the tests for it, we have the infrastructure, we have the security, we have the package updates. Overall, it increases complexity, right? It increases our cognitive overhead. So more abstractions over this, I don't think is the way forward for us, right? So I want to, before I dive into, time is just cruising by, so before I dive into talking about some of the approaches to dealing with this boundary complexity that I think the Elm community is innovating on because of the properties of the Elm language, I just kind of wanted to talk about this idea. This is kind of the idea of DevX, right? So here on the left-hand side, we've got dev time. You're in your editor, you're coding, you're in your flow. You're not breaking your flow. So here, tooling that is fast and that is inline to your code, like maybe your LSP, your linter, if you're lucky enough for your linter to be quick enough, code formatting, anything that's happening as you're working, I'd say that this is kind of like the lowest risk, the lowest pain, right? It has the highest kind of benefit for us. In the middle, we've got anything I'd consider slow. So this is build, test, CI time. By build, I even mean like jumping out to compile something. I do a lot of stuff in Haskell. I don't even use GHCID. I usually jump into GHCI and manually recompile, so I will do a bunch of work and chunk it and come out. So I'd say this increases the risk and increases the pain a little bit. It would be nicer if it was all faster and I just had it instantly. And then the super slow iteration speed, right? So by iteration speed, I mean the time it takes for you to get negative feedback and address it. Runtime, it's all the previous things, except you got to make the pull request, get the reviews, deploy it into production. Even if you have amazing continuous delivery and you're deploying multiple times a day, it still could be hours before you find out. And how would you even find out? Do you have good monitoring? Like, what other systems do you have in place? Bad. Like, the further our feedback on the right is, I'd say that's bad. And the slower a confidence tool is, or the higher impedance a tool is, the more likely you end up moving it to the right. So if we don't have fast tools, we end up kind of throwing them to CI. And I'm sure many of you have had this experience of useful tooling that kind of kicks you much further away from the point at which you're developing. So here is another question for you. And the question is, someone on our backend team changed a field name in the API. We will find out, some of you may work on multiple projects, so think of the worst case, the project that is worst case for you. We'll find out at dev time. You'll literally find out as you're coding. It'll interrupt you. You'll be like, something's changed. You'll find out at build test CI time, or you'll find out at runtime. Okay. So a lot of people sitting in the middle there, all right? Some people got really nice setups. Apparently, you find out immediately. That's great. Okay, let's now do it again, but this time, a third party changed a field name in their API. We'll find out at. Will you find out literally as you're coding? Or will you have to run some sort of tool or wait for your CI? Or is this thing going to blow up in production? Right. So I think that motivates that it's a problem, right? Like, it would be nice if we had some strategies to deal with that. And I'm giving an example here, like an easy one for everyone to understand, like the idea of an API failing. But yeah, this happens in its own way for every semantic boundary, right? There is something that can change about the semantics on either side, and you will have failures, or your glue code will no longer be mapping the correct thing. So I want to go through a couple of strategies. This is stuff that I've seen in the Elm community. I'm going to speed through these, but basically, if you do a takeaway, it's shift, lift, or remove, right? So the first one, shifting of boundaries. We've got a tool called Elm Pages that I can't see my slide notes, but I forgot the exact tagline for it. Dylan's going to kill me. Sorry, Dylan. So Elm Pages is basically a SPA framework for Elm, but not like your normal frameworks that you might see in other languages. It just entirely leverages Elm. So it feels like almost entirely like you're writing Elm. And the cool thing that Elm Pages does is here's a normal Elm app before Elm Pages. So you've got your Elm. Here in this example, we're making a HTTP request, and we've got the glue in between, like the encoders and decoders, and for the HTTP handling, right? So Elm, because it's an exhaustive language and it's pure, we have to map everything explicitly, right? So we have this encoder-decoder system. We have to actually declare these are exact fields I'm expecting to get back with these types, and this is what happens if they're not here. Even if you're super, super, super sure that field is ever there, Elm will be like, nah, like you gotta, one day it won't be, so you gotta tell me what to do, right? There's no any type, there's no escape hatch, you have to be exhaustive. So what Elm Pages can do is it can take this concept, and because it's pure, and it's exhaustive, and we know that there's no runtime exceptions, that means it's basically isomorphic. It's not dependent, its execution is not dependent on its environment. We can shift it. So Elm Pages takes that whole set of code that you've written with no changes, and it shifts it into the build and the CI and the test time. What it gives you in return then is it gives you that type data in a format that is guaranteed to not fail with your current code, right? And it's type checked. And then that's, in terms of the build, that's what it does at runtime. So in runtime and deploy, when the page loads and that page depends on some data from the server, it pulls it from the server and it comes back in and it's guaranteed. Right? So what Elm Pages does is it shifts the uncertainty and the failure possibility into the build time, and it guarantees it at runtime. So obviously this works for static site approaches if you're not using this approach. If you're not using static sites, so you need dynamism, this particular bit isn't working. But it's nice as an illustration because we can take this further, right? So because Elm Pages has really fast dev tooling and it has a live server that can detect which parts of your code you're changing and what needs to be rehydrated, it goes further and it just shifts it all the way across. So the developer experience that you have with Elm Pages is that as you're kind of coding and thinking about this API that you're interacting with, Elm Pages is consistently verifying that your implementation is actually working, right? It's cutting out the uncertainty and it's giving you a lot of confidence back. There's way more. This is an entire talk. Dylan does a fantastic job in his talk, Types Without Borders, that I would thoroughly recommend. But this philosophy has really kind of spread into the Elm community of this idea of like, let's eliminate avoidable uncertainty. So shift boundaries, effective when you've got equivalency and it's exhaustive, right, the code that you're dealing with. And Elm specifically always gives us, like, it's impossible to not have this with Elm. So we've got the purity, the referential transparency, and the type inference that lets us have this. It's instant and fast. The Elm compiler is super fast. And it's convenient. With Elm Pages, it makes it built in. So that's when this approach works really well. The second approach is lifting boundaries into the code domain. This is a bit more work, but I think this works amazingly at scale. So the anecdote I have here is Elm and GQL at a billion-dollar company. So Vendor is a US-based company that do basically bulk procurement for your IT services, procurement and management of those contracts. And so they have this problem, which maybe a lot of you will resonate with. Those of you that, how many of you have experience with GraphQL or use GraphQL at work or something like it? Great. So you've got something in the front end, you're talking with your GraphQL. And again, like we said before, there's more layers here, right? So this time, the thing in the intermediary part is this GQL string. It's the query language string. You're taking your values and you have to convert it into GQL. And then you've got the whole HTTP part, right? So the nice thing about this is we've got direct visibility, right? We can look at the GQL string and there's no impedance to the abstraction there. Like we look at it and we see what it is, we know what's getting sent. But the ergonomics suck, right? Like you're concatenating strings or something, maybe in Elm, or doing string replacement, and your confidence is pretty low here. We have no concept of whether our query is still correct against what our schema might have changed to. Now, you can introduce an abstraction library, and I think this is what a lot of us do in other domains as well. Like those of you who are writing raw SQL directly, raise your hands. Put your hand down if it's for optimization. Okay, so there's like 2 people who write raw SQL without optimization. That's like big brain. You see why. But yeah, most of us are reaching for some sort of abstraction, right? And the reason that I say that this only kind of gives moderate confidence, right, like everything's a bit yellow, is because we take the abstraction and then we put an abstraction on it, right? Like the code, the library that we use is abstracting over the thing that was already an abstraction in its first place. So this, again, doesn't like give us full confidence, and then when things go wrong, I think you've all experienced this, things go really wrong when they go wrong, right? Like the errors that you get, or the indirection that you have for a query going bust because of your ORM, wherever it might be, is really hard to see. So again, another fantastic talk here. Matt talks about code gen with types for humans by humans. Bit meta, but what I'm about to explain, he uses the same technique on the code gen, right? Because code gen can be scary, it can seem like more glue code to maintain. The technique I'm about to describe, he uses on the code gen itself. So the code gen uses this technique to do code gen. So here's what happens. We've got Elm, we've got the GQL string, we've got our actual GraphQL server. We move the string to the side, we keep it. We just write raw GraphQL like normal. Elm code gen gets in the mix. It takes all of the strings, all of these queries, validates them against GraphQL, and it generates all of the Elm GQL functions for us to use based on the interfaces defined in those files. Then it gives us the type safety so that we use that from Elm, and we use it just as normal functions. Those functions, they've got description, documentation, they've got a set of inputs with clear types, and a clearly defined return value, and it's exhaustive, right? There's no surprises in here. And all of the stuff on the right side is checked as well. What does this look like in practice? Here's an error message from GQL where we've typoed, right, a field in one of our normal string files for GQL, right? So I was looking for this, ran into an issue, this is what I think. This is kind of directly modeled and basically looks identical to the Elm type error messages, right? So the idea with this is that the direct visibility is still maintained. We've got all those lovely ergonomics, right? Because we're not concatenating anything, we're dealing with directly with Elm. And we got confidence, right? Like all the layers in between, as per the original definition of what busts out of glue, is that we've got these external guarantees, right? There's something else. It is still it's still glue code in the 2 definitions that it's bridging a boundary, and it's not got business logic in it, but it no longer is non-immune to external changes to the semantics, right? Then extra cool stuff happens. Because you know everything that's going on, Elm code gen can generate input generations, right? It knows what the input types are, so it could enumerate over some of those and generate some test harnesses and mocks and things for you. So you really have like a lot of leverage here for no cost to you. This is how it feels to use this approach. You write your Elm as an Elm developer, and your backend developers come into the project and they don't see any crazy Elm stuff. They just look at GQL, and everybody's integrated, right? This is at dev time. It's super fast. So you're not even breaking out of your development flow for this, and this will work for a third party as well if you're validating against a third party schema. So check it out. It's public, open source, vendor Inc. Elm GQL built on top of Elm code gen. This approach works when it's instant and fast, when it's convenient. So the type inference makes that convenient, right? I don't have to learn some new thing. I get Elm type errors being like, oh, you send an int to get users, but expect a UUID, whatever it might be. Yeah, we have confidence, and it's meta because this technique I've described, a bit mind-bending, but the code gen library uses this itself for everything it generates. So if the Elm packages or APIs that you're using ever change, the code gen will have type errors or it will update itself. So it's not like it's generated heaps of code that you now have to maintain. That part's done for you as well. Okay, the last one, and really screaming through this now. The last approach is to remove boundaries. This is the simplest, perhaps the most obvious, but I think it's the most difficult, especially if you've got an existing application. You may just have no avenue to be able to do this. But about 5 years ago, actually in pursuit of the presentation software that I'm using now, trying to build the first version of this, I started on this path of like extreme glue aversion, is what I'd call it. So Lambda is a product that I've been working on, and here's how I think about it. If we were to remove absolutely all glue and all semantic boundaries from a web development scenario, web development use case, I think these are the primitives. Like this is the absolute simplest we could get it. We've got state on the back end, right? It has a view of the world. We have events, like things that happen on the back end, timers, subscriptions, jobs. We've got state on the front end, events on the front end, same thing, right? Inputs, responses, what the actual front end knows. And then there's events that go from the front end to the back end, so pieces of information, knowledge, and the same the other way back. I can't reduce this any further, and I don't think there's anything that's unrepresentable with these primitives. But if I'm wrong, let me know in the comments. So here's another way to draw this out as maybe more of an architecture, right? So we've got the front end, it's got its state, the events kind of loop in. We've got the events to the back end, events to the front end, back end's got its state, and the events kind of loop through. This, we kind of know this paradigm now. This is the Elm architecture. It bled into other areas, like in React, it bled there as Redux, which was inspired by the Elm architecture. I think a lot of our front-end reactive programming is like this now, whether you use Svelte, Vue, whatever it is, we have this paradigm, more or less. This middle thing, I think we've known for a long time. A lot of you probably recognize this as something akin to RPC. And at least, you know, we know that there's some isomorphic, or languages with isomorphic functionality. They're able to send messages back and forth, so remove a lot of that glue. But this last one, I think, is a little bit unknown. So something called memory images. So I pitched for a long time to people, like, what if we didn't have a database? And pretty much the general response I got was like, that's not possible and you're nuts. The question of should we use a database at all like seems crazy, but there's nothing like appealing to authority to really make your argument stronger. So I found eventually, before I had a name for it, that Martin Fowler wrote about memory images, right? And the takeaway, so you're not hearing it from me, you're hearing it from Martin Fowler. The question to consider is, should we use a database at all? In his, this is emphasis mine, for a long time the big argument against the memory image was size, but now commodity servers have more memory than we're used to having in disk. Anybody want to hazard a guess of what the largest memory amount you can provision on an Amazon or Google VM is currently? Sorry, what was that? 14 terabytes. How many of you have data sets, your working data sets, not your archive memory, your working data sets that you actually need for your app that's larger than 14 terabytes? I see nobody. Okay, something to think about. As a result, most working sets can now be held safely in memory, which I think we just saw. We noticed this a few years ago, but memory images are still relatively rare. He thinks that's changing. He thinks we're going to see an upsurge in this pattern, right? When did he make his prediction? In 2011. So it's been a hot minute, and I don't think it's still happened. I've been exploring with it. Lambda is a delightful platform for full-stack web apps. It's entirely Elm, and here's the architecture diagram for Lambda. Exactly what we just saw. These are primitives in Lambda. There is no additional stuff there. And additionally, every single part of this is typed. So one of the downsides that Martin Fowler talks about, like the things that maybe prevent memory image adoption, those problems that he expresses aren't a problem in Lambda. The ultimate impact of this is there's no glue code within your app at all. And additionally, because it's all Elm end-to-end, we get a second property, which is you have no runtime exceptions in practice. I think that's maybe hard to take in, so I'm going to try like visualize it for you and then relate it back to your own work to see if that it lands a bit more. So here we've got that thing that we were talking about before, and I'm going to start removing the bits that Lambda doesn't have, right? So the first things first is we've got first-class primitives, basically an RPC, for sending direct values to the backend. No decoding, can't fail, like literally the backend cannot send messages the front end doesn't know about and vice versa. We remove the querying and storage, right? Using a memory image approach, your data is live, actually very similar to what Simon and Tim were talking about in the verse programming language, what they're aiming for, this idea like it's a program that runs and it's just a single thing that never dies, right? And it's just there, it's like persistent RAM. The hosting deployment migrations are removed. We still have the migrations because we need type-safe migrations between versions, right, to deal with the version deployment issue where a front end deploys faster than a back end or whatever. So Lambda solves this and pushes everything forward in a type-safe way. The surface area then on continuous integration, package updates, and security updates all narrows down, right? Because we don't have this massive code surface to deal with. So the question that I have for you next then is, what percentage of your code, based on what you just saw, so you pull out at your apps again, on the products that you work on, what percentage would you say roughly is glue code? Okay. So a fairly large bulk of people are saying that glue code is somewhere between 20 to 40% of your app. So I think the big takeaway here is, where else would you see, in terms of the approaches that you've seen throughout your career for reducing complexity, where else would you see that amount of promise gains? Right? I really feel like it's those boundaries and tackling the boundaries that leads to a massive part of that. Okay, so this still may not be something that feels like it sinks in, so the very last thing I'm going to go through quickly is trying to make this, contextualizing this in how it actually sits. So the real-world implementation is basically an app that's got a bunch of UI, an API schema, a set of functionality that you implement. Lots of frameworks do this to kind of show what would it look like to build a real app in this, right? So I took the Elm real-world implementation, which was front-end only. It spoke to an existing non-Elm real-world backend API, right? It was just to show how would you do a front-end of Elm in the real world. And so I had this theory. What if I took this and I rewrote it to Lambda, what would happen? So if my theory around how much glue there is right, that there should be a lot of glue removed, but the catch is I'm doing a full implementation of the backend. So all of the functionality I'm adding to this. What actually happened was that I ended up with less code. So all I did is I just moved it. I didn't change any, I didn't add or remove any functionality. I just moved it into Lambda, got rid of all the glue, implemented an entire backend. I promise you I didn't do any code golf to mess with these numbers. Elm is a little bit more vertically verbose, so it's slightly skewed. But basically, the hole that was left by the glue was large enough to do the entire backend implementation and have negative code left over. I've documented this online in 2 PRs if you want to take a look, if you don't believe me. But yeah, you can see, you can play with it at real-world.lambda app, and the repo's open. So removing boundaries, these are effective when you have language, system, or level control. That's why I said this is almost impossible, very hard. And there's explicit gotchas in there, right, for type inference. The compiler will tell you when you're trying to do things specifically in the system that aren't possible. So takeaways, the unbearable weight of glue code increases uncertainty, increases complexity, increases cognitive load, and the strategies for it, shifting it, lifting it, removing those boundaries. But there's a caveat here, which is type inference and purity really allow us to tackle that boundary uncertainty. They allow us to do it ergonomically, and allows us to do it with confidence. And the clicker there is that without these things, we're forced to deal with that boundary uncertainty pretty much always by writing more code and increasing that complexity further. So if there's one thing for you to take away, it's to think about this, like recognizing those boundaries and thinking about whether or not you're buying into this maybe more than you need to. Cool, that's pretty much all for me. But the last thing I wanted to leave you with was live or die by the audience, right? So you can tell me how the talk was for you. But otherwise, thank you very much.
Thank you, Mario. We have lunch in 5 minutes, so unfortunately we're not having time for questions, but I'm sure Mario is happy to answer questions. I mean, I guess if people want to stick around, am I allowed to do questions for 5 minutes? Yeah? Does anyone have any questions? Great.
So somebody noted, while you're going to them, somebody noted that they hope that the comments are time-stamped or correlated. Yes, they are. So I will know when you made a comment. I'm not just going to be out of context reading a lot of comments. So yeah, thank you.
Right. When you have interop with different languages and different existing libraries, how does this fit in Lambda?
Yeah, I think the short answer is it doesn't. Like at least from my point of view, the only thing you can do is write more code. You can write tests. If you're in a language where you have some of the guarantees like Elm, you could try like the code gen approach. if you can find some sort of stable or parsable definition for what that is. But the reason I mentioned that that was something done at a billion-dollar company is because that takes a lot of resources, right? And for them, when they've got a massive group of engineers, there's a lot of leverage in investing in that. And they actually have the capability to do it because they are 100% on Elm, right? Whereas, yeah, without those things, I don't know. I would love to hear from somebody if they have a way of doing that without more glue code. You know, I know I'm not very familiar with it. I know in the Clojure community there's been a lot of talk of the spec thing. I'd love to learn more about it, but from what I understand, you do have to write more stuff, and if invariants change, you have to change those specs, right? So I so far haven't seen a different approach. Yeah, I really don't know. That's a great question. Thank you.
Oh, there's more questions.
Thanks for a great talk. So I have a question about the memory image approach and keeping all your data in memory. So one way to deal with that when we have to restart the app, for example, because of, I don't know, a pod migration.
Yeah, absolutely.
Do you actually save the state, save the memory somewhere at all, or do you just reconstruct it from the event stream?
Yeah, I'm going to answer your question by asking a question. How many of you here work with like high performance database scenarios? A couple of you. How many of you basically get to a point where you have like in-memory caching enabled for those databases? How many of you get to the point where the hot path for that is so live that your database is basically in memory like 24/7, or you put it into a memory baseline image? Right. So what we already have is we've got a scenario where we take an architecture that we know pretty well, so like the write-ahead log, which in some ways you could look at as event sourcing. We got this log. We're really concerned about the persistence of this log, right? That's where we derive our ACID properties from. So we really, really worry about the persistence of the log. But once that's sorted, if you've got a particular setting that you would have for high performance anyway, the whole thing's living in memory, right? So when I was talking about the architecture here, notice that when we're looking at the far right-hand side, there's that event there. So the events that are being processed by the backend, that's the write-ahead log. And because it's pure and exhaustive, the model is entirely a function of all of the events replayed. So you get two cool things. One, this is how Lambda does its persistence and resilience. So if a Lambda app crashes, it can literally just be restored and replayed. The second thing you get is, by virtue of the architecture, point-in-time recovery. You can live time travel to any point in your backend state just by virtue of how it's set up. So I think this is what Martin Fowler talks about in the memory image approach. And the downsides that he mentions is, what if your event source store changes, right? What if your schema changes? What if your code changes and you can no longer replay that state? He's like, that's a big issue. And in Lambda, we just skip that entirely. I can give you more details on that if you're interested. Does that answer your question? Awesome, thank you.